5.5 day 1. I'm only going to do 2 problems today to help you out with the homework. I'm going to take a look at one where we are finding all the solutions of a trig equation over the interval from 0 to 2 pi, and what makes this different compared to all the other ones that we've been doing, at least so far this chapter, is the angles are different. Like the trig function is the same, but the angles are different. It's kind of like having a different variable. I don't want that. So how do I fix that? And then finding the exact value of the sine of 2u, the cosine of 2u, tangent of 2u, using a double angle formula for, and then here's your actual problem. They tell you the cotangent of u is equal to -4, and it looks like it's in the 4th quadrant. Alright, so back to the first one. How do I find the solutions of this particular equation? Well, remember what we've always been saying. You would love to have the same trig equation. I do. They're both cosines. We didn't really talk about it a lot because it's not been happening, but I also want these angles to be the same, and they're not. So now that kind of clues me in to say, okay, I probably need to use an identity to fix this. So I'm going to go ahead and look at my double angle formulas and say, what can I change this into? Well, for the cosine of 2u, or 2x, however you want to look at it, there's actually 3 of them that you could change it into. I could change this problem into cosine squared x minus sine squared x. And then I could have minus cosine x is equal to 0. Or I could change it into, this would also change into 2 cosine squared x minus 1. And then of course I still have minus cosine x equals 0. Or I could change this into 1 minus 2 sine squared x, then minus cosine x equals 0. So the cosine 2x function is one of the few ones that has multiple identities that you could use. I can use any one of these equations, whichever one I want to. Now, like we've said before, you want to have the same trig function, so that one looks like it would be the best one. Can I use those two? Yeah, I can. What could I do? I could change sine squared into 1 minus cosine squared. I could change sine squared into 1 minus cosine squared, and it eventually would simplify to this. So obviously I'm going to use this because it's a lot quicker. So I'm going to change this into 2 cosine squared x minus cosine x minus 1 equals 0. So now I've just got it in standard form. And now I can go ahead and I can try to factor, or use a quadratic formula if I need to. So I know this will quickly factor, but I'll run through the earmuff or the multiplying front and back. If I multiply the front and back, I get -2. Factors of -2 that'll add to give me 1 are -2 and 1. So this would be 2. I'm going to change the cosines into x squareds, and then I'll change them back to cosines in a second. So this is 2x squared minus 2x plus 1x minus 1. Or again, you can put cosine squared x, cosine, cosine if you want to. And then if you do our little factor by grouping trick, factor out what they have in common. They have 2x in common. You're left with x minus 1. Factor out what these have in common. They don't have anything in common other than 1. Something has to get factored out, so factor out the 1. And so it factors into 2x plus 1, or remember it's actually 2 cosine x plus 1. And then the parentheses are the same. That would be cosine x minus 1. And now I just have to solve each separately. So I've got the cosine of x is equal to -1/2 if I set that equal to 0 and solve. Draw my little circle. It's cosine, so it's an x value. It's left or right. It's negative, so it's going to the left. If it's a 1/2, I know that's a reference angle of 60 degrees, or pi over 3. So this would be 2 pi over 3 and 4 pi over 3. So there are the two answers for this part of it. Over here, I get the cosine of x is equal to +1. It's one of the rare occasions that you get just one answer. That's right here. Again, because of the restriction, even though 2 pi and 0 are the same thing, according to that restriction, they do not want 2 pi for an answer. So 0 is the answer that you would want to give. So your answers are 0, 2 pi over 3, and 4 pi over 3. Alright, so anytime you're given a problem, if you notice that these angles are different, that should tell you, okay, that's what I need to work on, get those angles to be the same. Alright, the other problem I'll do for you today is going to look similar to the problems that you get in the 20s, the mid-20s, where they're asking me to find the exact value of the sine of 2u, cosine 2u, tangent 2u. Well, notice what they gave me. They didn't give me cotangent of 2u. They gave me cotangent of u, which means I need to use the identity. Before I worry about that identity, I'm going to draw a triangle for this. So, according to this, it's cotangent, so I would probably switch it into one of the three that I'm most familiar with, the sine, cosine, or tangent. I'm going to switch it into tangent, it's the reciprocal. So I'm saying that the tangent of u is negative 1/4. So when I draw that triangle in the fourth quadrant, pay attention to the restrictions, it means it's going to look something like this. Please make that triangle look accurate. The tangent is opposite over adjacent, so negative 1 here, 4 here. I know that one's negative because it went down. And then if I use my Pythagorean theorem, I have 16 plus 1, or this will be the square root of 17. And there's angle u. Now, how do I find the sine of 2u? Well, look at its identity. The sine of 2u is actually equal to 2 times the sine of u times the cosine of u. So even though I'm trying to find the sine of 2u, it uses u, which means I can use that triangle. So this is going to equal 2. What's the sine of u? Sine of u is negative 1 over square root of 17. Cosine of u is 4 over the square root of 17. And you can probably see why I didn't rationalize those things. Multiplying this all out, it looks like I'm going to have negative 8 in the numerator, 17 in the denominator. There is what the sine of 2u is. Cosine of 2u, of course, is doing the same thing. Now I have three different identities that I can use for the cosine, so really you can pick whichever one you want. It's not going to make a difference. I'm going to pick just random. I'm going to pick 1 minus 2 sine squared u. Again, no reason. And if I substitute in, this is of course 1 minus 2 times the sine of u is negative 1 over square root of 17. And then that gets squared. So that's going to end up giving me, if I do this, well, let's just do it. It's 1 minus 2 times 1 over 17. So that's going to give me 1 minus 2 seventeenths. And if I get my common denominator, 17 over 17, I'm eventually going to get 15 seventeenths. So now I've got the sine, I've got the cosine. The only thing I don't have is the tangent, and so we'll find that next. And so looking for the tangent, you can do a couple different things. You, of course, can just look at your identities, which is what I'm going to do. And my identity for the tangent of 2u is, and again, if you have an identity where you have more than one, you're welcome to use whichever one. For the tangent of 2u, it's equal to 2 tangent u divided by 1 minus tangent squared u. The only time that you should have to worry about multiple formulas is when you're dealing with the cosine of 2u. And now I'm just going to plug my information in. This is going to be 2 times the tangent of u. Tangent is negative 1/4 divided by 1 minus the tangent squared. So negative 1/4 squared. And simplifying, I end up with negative 1/2 in the numerator divided by 1 minus squaring. That's going to give me 1/16. And so I am going to end up with negative 1/2 still in my numerator. Denominator is 16 over 16, so that's going to eventually be 15 over 16. And now when I multiply by the reciprocal, again, simplify ahead of time, that's going to give me negative 8/15. Now, realistically, if I was doing this problem, would I actually do this? Probably not. What could I do? Well, as long as these angles are all the same, what is tangent? It's sine divided by cosine. It would be sine negative 8/17 divided by cosine 15/17. Multiply by the reciprocal, and you end up with negative 8/15. And of course, same thing. So once you've got the sine and cosine, you can find the tangent by just dividing the two. That's what I would do. Not a bad idea to run through this in case I asked just for that on the test. Because if I asked just for the tangent of 2u, it would be kind of a waste of time to find both of those when you can just plug it in here. All right, hope that'll help for section 1 of 5.5. If not, you're always free to come in and ask for help.